Hello friends, in this video I'd like to solve the following problem from the Pan-African Mathematics Olympiad 2021, problem number 5. We want to find all functions f from the set of real numbers into itself, satisfying the following functional equation. F of x plus y times f of y plus x equals f of x squared plus f of y squared plus 2 times f of x times y for all real numbers x and y. So my hints for this problem: try first setting y to be 0 and try to derive the formula for f of x squared. Then try to set y to be 1, sorry, and that should be sufficient to find f of x. And finally, make sure to verify your result in the end. So give this problem a try and I will see you in a moment. Okay, so as I suggested, let's start by setting y to be 0. What happens then? Then we have the following: f of x plus 0 times f of 0 plus x equals f of x squared plus f of 0 plus 2 times f of 0. So it's plus 3 times f of 0. And that means that f of x squared equals x times f of x plus f of 0 times f of x minus 3 times f of 0. And okay, very well. And now let's call our first equation asterisk, and now our condition asterisk becomes the following: f of x plus y times f of y plus x equals, instead of f of x squared, I can write the derived formula. Instead of y squared, I can put also the derived formula because it works for every number, so it also works for y. And finally, we have plus 2f of x times y. And you know what? Maybe I will do one more thing. I will expand the left-hand side, because on the left-hand side I have f of x times f of y plus x times f of x plus y times f of y plus xy. Okay. And now let's do some simplification, because what can we do? Here we have x times f of x, here we have it as well. Here we have y f of y, here we have y times f of y as well. So we have the following: f of x times f of y plus x times y equals f of 0 times f of x plus f of 0 times f of y plus 2 times f of x times y minus 6 times f of 0. Okay, very nice, very well. And now let's set y to be 1. Let's set y to be 1. What happens then? Then we get the following: f of 1 times f of x plus x equals f of 0 times f of 1, f of 0 times f of x plus f of 0 times f of 1 plus 2 times f of x minus 6 times f of 0, sorry. And now let's put everything with f of x on the right hand side, everything without f of x on the left hand side. So on the left hand side we will have x, f of 0, f of 1, 6 times f of 0. So I will have x plus 6 times f of 0 minus f of 0 f of 1 equals, and on the right hand side I will have minus f of 1 plus f of 0 plus 2. So 2 plus f of 0 minus f of 1 times f of x. Okay. And maybe I will put this formula bigger and lower. And remember that this should be true for every real number x. This holds for every real number x. Okay. And now let's notice that that means, in particular, that 2 plus f of 0 minus f of 1 cannot be 0. Why is that? Well, if it were to be 0, that would mean that we will have x plus some constant equals 0. But x is arbitrary. So x plus a constant cannot be constantly equal to 0, because x varies. And in turn, that means that we have an explicit formula for f of x, namely f of x equals x plus 6 times f of 0 minus f of 0 f of 1 over 2 plus f of 0 minus f of 1. And if you look closely, here we have 1, here we have 1 over some constant. So 1 over some constant is another constant, it's, let's say, a. And here we have constant over other constant, it's something like b. So our function, in other words, is affine. F of x equals ax plus b for some constants a and b. Okay, so now we know pretty much almost everything about our function. We know that it is affine. And now, as I said, we must do verification. We must do verification to see which constants a and b will work. So let's add another page. Very well. Verification. 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 So let's take again our equation. Recall that it was f of x plus y times f of y plus x equals f of x squared plus f of y squared plus twice f of x times y. And now I will put this formula. And we have the following: ax plus b plus y times ay plus b plus x equals ax squared plus b plus ay squared plus b plus 2 times axy plus b. And now it's a matter of simplification, of writing everything separately. I will do a leap here, and after simplification we will get a squared minus 2 times a plus 1 times xy plus ab plus b times x times y, times x plus y plus b squared minus 4 times b should be equal 0 for every x and y, for every real x and y. But that means it's pretty easy to see that that can be only true if this is 0, this is 0, and this is 0 as well. Okay, so since this part is a minus 1 squared, a minus 1 squared equals 0, that means that a equals 1. A equals 1 means that 2 times b must be equal to 0, so b equals 0. And if b equals 0, we see that b squared minus 4 times b is 0 as well. So in fact, we have only one solution. The only solution is f of x equals x. Identity of a set of real numbers. It's the only possible function which satisfies our functional equation. Yes. So thank you for watching. I hope that you learned something. I hope that you didn't skip the verification step. It's very important, as you see, because instead of infinitely many solutions, we are left with only one solution. So it's very important to verify your answer. And yes, that is it. See you next time. Goodbye.